Alright, so this video is going to be about working with logarithms. But I think before we do that, I better explain where logarithms come from. And then there's a long explanation, but we can go to the short one here. So let me go ahead and put this up. So, logarithms. So let's say I had 4 to the x power equals 16. Right? So 4 to what power equals 16? Now most of you would probably say, well, duh, it's 2 because 4 squared is 16. You're correct. 4 squared equals 16. But you obviously might encounter more difficult problems like 3 to what power equals 12. That's not as easy. You can't say, oh, 3 squared because 3 squared is 9, or 3 to the third power is 27. So I don't know what power equals 12. So there's this ingenious idea. It's basically the inverse of a exponential equation, such as 3 to the x. Just like how when we solve with algebra, we do the inverse, like we subtract from both sides, we divide when it's multiplied. So this would be the inverse operation to solve an exponential equation like this. And it's called a logarithm. Oh, sorry. So logarithm. So essentially, a logarithm is the easiest way to define it is how we solve exponents. So if we want to find out what the exponent is, we use a logarithm to solve it. So let's take my example here, my first one here. 4 to the x equals 16. And we already know the answer is 2. But this is how we can change it from exponential form to logarithmic form to solve the logarithm. So 4 right here is the base, right? So 4 to the x power. 4 is the base of the exponent. So when we write it in logarithmic form, it is the base of the logarithm. So we pronounce that log base 4. So 4 is the base of the exponent. 4 is still going to be the base, but now it's the base of the logarithm. And then the easiest way to describe this is that the exponent and whatever the equation equals switch places. So it would be log base 4 of 16 equals x. So notice how I got x all by itself, right? Because when we solve with algebra, we try to get x by itself, or the variable by itself, to find out what the answer is going to be. And notice how I have this expression over here, log base 4 of 16, or log 4 of 16, whatever you want to pronounce it. So you can actually, if you have a calculator, you can type that in and get an answer. Now I'll go ahead and spoil the fun for you. We already know that x is going to be 2. So log base 4 of 16 is an answer of 2. But you can actually plug that expression in to find out what x equals. Okay? So that is how we change it from logarithmic form, or excuse me, from exponential form to logarithmic form. Okay? So let's do another. So the other example I gave us, so 3 to the x equals 12. 3 is the base of the exponent, so it's going to be the base of my logarithm, so log base 3, and x and 12 will switch places. Okay, so log base 3 of 12, I don't have my calculator in front of me at this current moment, but it's going to be something greater than 2, right? Because if 3 squared is 9, and 3 to the third power is 27, it's definitely going to be closer to the 2 range, so it's going to be x equals, we'll say 2.2. I'm guessing. You can pull out a calculator, and we'll talk about in class how to actually type it into the calculator. But so that is what that would be, because we use logarithms to solve for exponents, and not all exponents will be nice exponents. Okay, so that is simply how you change an equation from exponential form to logarithmic form. But of course, if you can go one way, meaning go from exponential to logarithmic, you can go from logarithmic to exponential. So let's say I had this. Let's say I had log 12 equals, no, let's do it this way. Let's say I have log x equals 3. Or equals 100, then we'll do that one. So log x equals 100. So you might be saying, well, wait, there's no base on the logarithm. Like usually there's a little number, kind of like how I had log base 3, so you had that little 3 down there. But notice how I don't have a number right here. There's no number there. So In a logarithm, the whole reason that logarithms exist is that there's an assumption being made that there's a base 10. Which, why is it a base 10? It's base 10 because we in America, or here in the United States, we have a decimal number system, or a base 10 counting system. So remember in grade school when you learned that the ones column is the tens column, the hundreds column, the thousands column. Those are all different powers of 10. So we use a base 10 counting system or a decimal counting system. So logarithms are assumed on that. So if the base isn't written, so if we don't know it's base 3, we assume that it's base 10. So if there's no base there, assume it's 10. And this is how we change it from logarithmic form to exponential form. So the base of the logarithm is 10, so that's going to be the base of my exponent. So 10 to some power equals something. And remember in the previous example how the exponent and whatever it equals switch places? They just switch back. So it would be 10 to the 100th power equals x. So that is how we would solve that. So that logarithm is solved by doing the opposite. We go from logarithmic to exponential form, and 10 to the 100th power will give us our answer. So let's do another one. Let's say I had log base 5 of x equals 3. Again, we could change this to logarithmic form. The base of my logarithm is the base of my exponent. X and 3 switch places. So it would be 5 to the third equals x. And again, you plug into your calculator, 5 to the third actually equals 125. So there is switching from logarithmic form to exponential form, and exponential to logarithmic form. And that is the basics of how you, and obviously you could switch back and forth between the two to get x by itself. The whole goal is we want to find out what x is. And a lot of students say, I don't know which form to go to. Well, if it's in one form and you can't figure it out, switch it and see if the variable moves into the correct spot. So that is how we change forms from either exponential to logarithmic or from logarithmic to exponential.